Or you could generate the key based on some master secret in a microcontroller, but then you have to transmit the key over the bus to the reader IC, so it can be sniffed on the bus. So you have a trade-off of whether you want to store 32 keys in the IC or want to transmit them in the clear over the bus. Okay, I see we don't have any more questions. Then, oh, question in the back?
Some access control system based on MIFARE only reads the ID of the MIFARE card, and then they say you can get in or you cannot get in. Is it possible with the OpenPCD to copy that ID and...
Not with the OpenPCD, but with the OpenPICC, which is the sister project for a card emulator. I originally planned to present that at this Congress, but I didn't quite get it working because of the timing issues I mentioned earlier. To get that properly working, I need to have a jitter below, approximately below 100 nanoseconds, and I'm not quite there yet. But in principle, the unique identifier that is transmitted at the start of transaction is not encrypted and not secured in any way. I'll have something about that too in just a second or two.
But we will emulate the tag, yes.
And there is a second, there's one unique identifier that's transmitted at the start of transaction in the anti-collision procedure. And the unique identifier is stored on the card in the memory of the card, and you can read it from the card. That you can't spoof with this technique, with just spoofing the transmitted anti-collision identifier, but you can probably, or I will show you, you can probably spoof it through some other measures I'll present shortly.
But to answer the part of your question about systems that rely solely on the unique ID of the card, that's what Philips calls basic security levels. No security level at all. But as long as you don't have a VLSI fab, you can't actually copy a tag and make another tag that has the exact functionality and the same random number. So there is some security. But in any application where you could just as well bring in some device hidden underneath your clothes or any of that, where you don't actually have to have it to be an RFID tag. You can easily spoof the unique ID.
That's the OpenPICC. Looks just like Milos presented at last year's Congress. Has about the same format as the standard card and can in theory implement and send any unique identifier that you want. I'll have that now. Okay, for the for our in order to be able to play around with timing or to analyze the protocol in any way at all, we needed to be able to sniff the communication to verify our findings of the circuit. And the sniffing setup, I think we shortly described it at the camp this year, consists of the OpenPCD reader, or in principle you can use any reader that's based on the same reader IC, and an OpenPICC card emulator. Because the cool thing of these is that the reader can be set up so that it will output the signal that it received from the card on some digital output. The reader outputs the card signal, and you can set up the card, or it's set up by default, so that it will output the signal that it received from the reader on a digital output. The card outputs the reader signal. That's what you have here. The reader sends something to the MIFARE card, and because this is radio, it's also received by our OpenPICC and sent out through a digital output. And the MIFARE card answers, which is received by the reader and output through a digital output. Then Milos has a cute little logic analyzer that you can connect to a universal serial bus, and it can capture several thousand or 100,000 samples with 10 nanosecond resolution, which we just connect to both of these signals, and then we get the reader to card and card to reader communication crystal clear, just as it was transmitted over the air without any interference and no analog signal processing whatsoever. Don't worry about that. The signal here is mirrored here, and just ignore that one. I did that in my encoder decoder. Yeah, the signal here is not the real data signal. It's not the data. It's not 0, 1, 1, 0, 1, 0, but it's actually the module, the encoded signal. So this is from reader to card is Miller coded, and from card to reader is Manchester coded. But that's easy to decode, and we have a decoder that will just take the output from the logic analyzer and give us the frames that were transmitted in both directions. Two-way sniffing. Question?
We have a microphone?
Micro's in the back.
Just to clarify, so if I can actually intercept the communication on the radio channel between the card and the writer, when the writer is actually writing to the card, I can then brute force the key within a week and then write myself to the card, or write the stuff myself to this card.
Yeah, should be possible. It's a simple brute forcing. As soon as you know the algorithm, you can brute force implement it outside of the card, because the card will only do about 8 tries per second, and if you can brute force it in an FPGA, you can brute force it as fast as you want, and then 48 bits is not enough.
There's a lot of things that's going to change.
Start migrating.
There is some dependency to the implementation, because you can specify a different password depending on access level. So it could be, in theory, there is a different key that you don't see.
Okay, yeah, the MIFARE system has 2 keys per sector, and the 2 keys can be assigned different writes. You can have write writes and read writes, and but I'll show you something neat about these in about 3 minutes. You will be surprised. I was. Okay, and that's the timing setup that I have. You have the OpenPICC down here. You have just about any MIFARE card in the middle, and that's the OpenPCD and the OpenPICC up here. That's the digital output from the signal that was received from the reader, and that's the digital output that was received from the card. And Milos made me a neat cable, which has just a standard mini USB cable, which has a power switch in the power line, so I don't have to plug in and plug out the USB cable all the time. And on the OpenPCD, I had firmware running that was originally written by Harald that I modified so that it will just start authenticating and reading as soon as it's powered on. Or I think that's the original function, and I have only some more output. And what I then did is, What I then did is turn everything off, start capturing on the logic analyzer, switch on the power to the PCD. The PCD will boot its firmware. The firmware will automatically start authenticating to the card. The card was powered on at the same moment that the firmware booted and turned on the field. And it's authenticating, reading. I can see the output. Then I stop the capture, get out the capture from, get the captured data, put it through my decoder, see which frames were transmitted, and return to step 1, power off, power on, and so on. This were the first few of these transactions that I captured. I actually snipped out everything that's not the challenge response protocol. There's a mutual authentication protocol that's initiated by the reader. Then the card answers with its random number. That's 32 bits of randomness that are only 16-bit random. The reader answers with challenge and response, something they claim they have implemented something based on ISO 9798-2, but that's actually not possible based on the length of these. That's standard mutual authentication. And then that's challenge, response, new challenge, response. That's one possible interpretation. We don't know exactly, or at least I don't know, maybe Carsten has some more insight. And what you see now is that if I do that a few times, switch everything off, switch it on, and as soon as it's switched on, or sometime relatively fixed time after switching on, it will authenticate for the first time, you see that the card's random number generator somehow has a bad day and is outputting the same data over and over. I was kind of confused when I saw that earlier. I thought I had mixed up the files and was decoding the wrong data set, but no, that was the correct data set. And what you also see, that's the card random number generator. What you also see is that the reader random number generator is also not such a good day. It's not as often as the card, it's not repeating itself as often because there's more time in between and there can be interrupts in the firmware that will delay the timing for a few microseconds and so on. But it's actually quite often that the reader will also have the same random sequence over and over again. These were the first few, and then I have a collection of 27 trials. It's actually quite time-consuming, switching off and manually starting the capture in the Windows software with clicking and then stopping and clicking and exporting. Can't be automated. So I took half an hour about to make these 27 trials. And then I grabbed out and set it and unique and whatever with a Unix pipeline, the mutual with authentication pairs and sorted them. And these are the random numbers generated by the card and the first response by the reader. And it's sorted and every line is counted. And you see, this is our winner. This combination occurred 6 times in our 27 trials. And most of the other ones occurred multiple times too. So that's basically the random number, and the challenge response is completely broken, not by us, but by design.
But even if that weren't the case, 16-bit random numbers means you listen in on 128 transactions, and then after an expected number of another 128, you see one of the challenges again. So without any control over the randomness here, you will break it in matters of minutes.
Mm-hmm. And Carsten didn't mention that number before. 65,000 possible combinations at 9.44 microseconds per shifting means that the random number cycle repeats every 0.7 seconds. Okay, and so basically we can control, that's the interesting thing, I didn't intentionally insert anything into the firmware to control the timing. It was just so by default. If I had introduced some precise timing to not start the authentication procedure as early as possible, but at a specified time, I would have had the same tuples over and over. And if you can control the timing, you have basically, for example, a replay attack. You listen to one transaction, and then you make that card send the same random number again, and then can replay the reader side of the communication, and the card will do its same responses over and over. And because the MyFair cards have a parse feature, you can designate sectors or blocks as a monetary value, and then have a transaction that not means write something to that sector, but increment the value in that sector by €5, and you replay the increment transaction over and over. Free lunch. There was another interesting thing, or much more interesting breaking thing. When I heard of Carsten's results, we were not quite sure how the initial state of the shift register of the cipher is set up. We don't know exactly. But he said that there are not enough inputs for unique identifier and key and all at the same time.